Every second, Tesla produces up to 536 battery cells, a number that clearly shows how they are dominating the energy industry. Behind the scenes, the company has built the largest lithium refinery outside of China, located in Texas. From Nevada to Shanghai, Tesla's global network of Gigafactories is running at full capacity. So, what secrets lie behind this electric battery race? Before we begin, please help us reach 9,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. How is Tesla able to produce 500 battery cells in just 1 second? Tesla's battery breakthrough in 2025 is reaching an unprecedented scale with plans to produce over 500 battery cells every second, specifically 536 cells. The company's battery technology has evolved far beyond the early 1865 zero cells once used in the Model S and X. In 2017, Tesla introduced the 2170 cell for the Model 3 and Y, which delivered higher energy density and lower costs. Yet Tesla continued to innovate. At Battery Day in 2020, the automaker unveiled the 4680 cell, a revolutionary tabless design that lowers electrical resistance, improves performance, and significantly reduces manufacturing costs. This advanced cell is expected to be the key enabler of the long-promised $25,000 electric vehicle. However, scaling up 4,680 production remains a challenge, especially with Tesla gradually implementing dry electrode manufacturing across its domestic LFP battery lines in the United States. Tesla's ambitions go beyond EV batteries. The company has become a major force in the energy storage sector with products like Powerwall and Megapack. Giga Nevada remains the primary battery production hub, while the facility in Lathrop, California focuses on large-scale energy storage systems. Looking ahead, Tesla is ramping up development of lithium iron phosphate batteries, which are known for their lower cost and longer lifespan. It is also closely watching the progress of solid-state battery technology, which offers potential for higher energy density and faster charging. In this transition, materials are critical. Lithium enables charge movement, nickel enhances energy density, cobalt stabilizes the cathode, and graphite is indispensable for the anode. Unlike most automakers that heavily depend on external suppliers, Tesla pursues a vertically integrated approach. The company is even building its own lithium refinery in Texas to secure a steady supply of raw materials. After extraction, these materials must go through important refining steps, including separating into anode and cathode materials, which are then coated onto metal foils to create electrodes. Tesla is advancing dry electrode technology to shorten this process and boost sustainability. Tesla typically uses cylindrical cells, which are made by stacking cathode, anode, and separator layers, then undergoing formation and aging cycles to ensure durability. Once complete, the cells are assembled into modules and battery packs for vehicles. However, Tesla is moving towards cell-to-pack technology, which skips the module stage to reduce weight and increase energy density. Production volume has grown rapidly. In 2024 alone, Tesla sold over 1.78 million vehicles, requiring nearly 7 billion battery cells. For example, a standard Model 3 or Y uses around 2,976 cells. The long-range version needs 4,416 cells. The Model S and X require about 7,180 cells, and each Cybertruck contains around 1,344 cells. Beyond vehicles, Tesla's energy storage products like Powerwall and Megapack could consume up to 10 billion cells, which might even exceed demand from its automotive segment. To meet this massive demand, Tesla works with a range of major partners. Panasonic, a long-standing partner since 2010, remains a key player. LG Energy Solution supplies 2,170 cells for Model 3 and Y vehicles from Tesla's factories in Shanghai and Berlin. CATL, the world's largest battery producer, provides LFP cells, while BYD contributes as both a battery supplier and a direct EV competitor. Interestingly, BYD is not only a supplier, but also Tesla's strongest rival, especially in China. Founded in 1995 to manufacture mobile phone batteries, BYD shifted to lithium-ion battery production in the 2000s and launched its first plug-in hybrid in 2008. In 2020, the company introduced its Blade battery, which paved the way for a collaboration with Tesla that began supplying batteries to Giga Berlin in 2023. This complex partnership is similar to how Apple once relied on Samsung for iPhone display panels, despite being fierce competitors. One of BYD's major contributions to Tesla is its lithium iron phosphate batteries. These LFP cells have lower energy density than NMC batteries, but offer longer lifespans and lower production costs. They are used in the standard versions of Tesla's Model 3 and Y products, essential to lowering prices and bringing electric vehicles to the mass market. While continuing to rely on suppliers like BYD, Tesla is steadily building its internal battery manufacturing capabilities. After acquiring Maxwell Technologies in 2019, Tesla enhanced its dry electrode process, forming the foundation for the 4680 cell introduced in 2020. So far, Tesla has produced over 100 million 4680 cells and is scaling operations at Gigafactory, Nevada, with the aim of reaching 100 gigawatt hours per year, which would be enough for around 1 million electric vehicles in China, accounting for about 40% of all battery cells in these models. Although Tesla has also tested LFP usage in the United States, it still depends heavily on a broad supply network due to supply chain constraints. Expanding the use of LFP cells is seen as 1.5 million EVs. However, to meet growing demand, Tesla still needs external suppliers such as Panasonic, LG, Samsung, and more recently Eve Energy from China. This shows Tesla's balanced strategy between self-sufficiency and leveraging global industrial partners. Once again, please help us reach 9,500 subscribers. This is important for us to stay motivated. Thank you. Why is reaching full capacity at Tesla's lithium refinery important? Tesla is rapidly advancing toward its goal of securing a self-reliant lithium supply, thanks to remarkable progress at its lithium refinery under construction in Robstown, Texas. Recent aerial images shared by veteran construction tracker Joe Tegmeyer reveal a series of major developments. The foundation for production line 1 has been completed. Preparations for line 2 are underway. A new electrical substation has been installed, and key equipment such as rotary kilns and cooling systems are being positioned. The long-term target of this facility is to produce up to 50 gigawatt-hours of lithium annually, enough to supply batteries for millions of Tesla electric vehicles. Although originally planned to begin operations in the first quarter of 2025, Tesla achieved a major milestone ahead of schedule. In the fourth quarter of the 2024 fiscal year, the company announced it had successfully refined its first batch of spodumene, a lithium-bearing mineral, just 18 months after breaking ground. This is considered one of the fastest construction and commissioning timelines ever recorded outside of Asia. Simultaneously, Tesla is ramping up hiring efforts at the facility, with more than 40 technical and managerial positions currently open, including roles like metallurgical engineers, logistics supervisors, and area managers, signaling an urgent push to staff the facility at full capacity by 2025. Beyond building a domestic lithium supply chain, Tesla is also investing heavily in 3 core pillars of battery innovation: faster charging, higher energy density, and longer battery lifespan. The company has introduced a new generation of superchargers with outputs of up to 500 kilowatts, enabling vehicles like the Cybertruck to charge significantly faster. Next-gen battery research is also targeting a lifespan of up to 1 million miles and extended driving ranges without increasing battery size or weight, part of a broader strategy to reduce production costs while boosting EV performance. Tesla's ambitions go beyond production. The company is also focused on creating a sustainable battery ecosystem through recycling. It has pledged to recover 100% of used lithium-ion batteries rather than discarding them. To realize this, Tesla is partnering with leading recycling firms such as Redwood Materials and Li-Cycle Pioneers in extracting valuable raw materials from old batteries. These efforts are laying the foundation for a closed-loop production system in the EV industry. Tesla isn't alone in the race to localize lithium supply in the U.S. Stardust Power, a rising player recently broke ground on a $1.2 billion lithium refinery in Muskogee, Oklahoma. Once operational, the plant aims to refine up to 50,000 tons of lithium annually, making it one of the largest lithium refineries in the United States. This reflects the urgent need for secure battery supply chains amid the surging demand for electric vehicles and energy storage systems. Tesla stands out with its vertically integrated strategy from mining and refining to production and recycling, demonstrating a clear path to control the entire value chain of clean energy. Stardust Power's project in Muskogee is considered a strategic move to strengthen America's domestic lithium supply, especially given the country's current heavy reliance on imports from China, Chile, and Australia. The project's first phase will establish a production line with a capacity of 25,000 tons of refined lithium per year. Once stable operations are achieved, Phase 2 will double that capacity to 50,000 tons annually, a significant figure in the current U.S. context. Choosing Muskogee, Oklahoma, was strategic. Centrally located for nationwide distribution, the region also offers a skilled workforce with experience in the oil and gas industry, a major advantage when operating complex chemical refining processes. This helps reduce training costs and ensures safe and efficient operations from day one. The project is also expected to qualify for up to $257 million in federal and state-level incentives, demonstrating strong U.S. government support for initiatives that reduce reliance on foreign lithium. These incentives will boost Stardust Power's competitiveness and accelerate its path to commercial operations. Tesla's and Stardust Power's lithium initiatives are not solely focused on meeting EV battery demand, but also on the growing need for grid-scale energy storage, which is expanding in tandem with renewable energy adoption. Tesla's next-generation batteries with improved energy density, faster charging, and million-mile durability could significantly lower long-term battery replacement costs. At the same time, recycling efforts led by companies like Redwood Materials and Li-Cycle will play a key role in building a circular economy, reusing critical materials and reducing dependence on raw resource extraction. What new Tesla models will use domestically refined lithium? The construction project of Stardust Power's lithium refining plant in Muskogee, Oklahoma, is being regarded as one of the most strategically important efforts to strengthen the domestic lithium supply chain in the United States, amid the rapidly growing demand for electric vehicle batteries. The acquisition of 66 acres of land in Muskogee in January 2025 marked a bold initial step by Stardust Power. Notably, the company had already secured all necessary permits in 2024, a thorough preparation that will help shorten the implementation timeline. Tesla is currently developing a new generation of batteries with higher energy density, faster charging capabilities, and a lifespan of up to 1 million miles breakthroughs that could significantly reduce future battery replacement costs. At the same time, ramping up lithium-ion battery recycling with companies like Redwood Materials and Li-Cycle taking the lead will help the U.S. build a circular economy, enabling the reuse of valuable materials instead of relying solely on virgin mining. With a combination of production expansion, technological investment, smart logistics, and strong policy support, Stardust Power's lithium refinery in Oklahoma is expected to become a key link in the U.S.'s strategy to achieve energy independence, reduce supply chain reliance, and promote sustainable growth in the EV industry. If it stays on schedule, this facility, along with Tesla and other strategic partners, could reshape the global lithium production map, transforming the U.S. from an importer into a leading refining hub in the green energy era. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.